Welcome to another lecture on complex variables and transforms, and in this lecture we will study Laplace transform of d by dt of f of t. Right, the time derivative of f of t. We know that time derivative of f of t can also be written as f prime of t. You can also write it as prime of t. So by definition, this is Laplace transform of the derivative of t. F prime of t is f prime of t e to the minus st integrated from 0 to infinity. So the same is solved using integration by parts. We have studied integration by parts many a times in the past. We declare one of the two functions as the first and the other function as the second function. Right, so let's consider this as the first function. We integrate it, and the second function is written as such. Right, it's as such. So it is integrated. The first function is integrated, and the second function is written as such. And then the first function integrated is once again written here. And the second function, which was written as such, is now differentiated. Here in this integral. Right, and we put limits, and we put these two quantities in these two terms in an integral. Right, now we put limits for this first integral. You put f of infinity e to the minus 0. E to the minus 0 comes out to be a 0, where e to the minus infinity comes out to be 0. 0 times f of infinity is 0, where e to the minus 0 is f1. So 1 times f of 0 is f of 0. Right, and for this second integral, this is minus into minus becomes plus. S is taken out of the integral because it is not the function of t, and what we are left with is f of t times e to the minus st integrated, and we know this whole is f of s. The Laplace transform of f of t. So rearranging terms here gives us Laplace transform of time derivative of s is s times f of s minus f of 0, where f of 0 is a value obtained by putting a 0 in the given function f, for which whose derivative is the one for which we are computing this Laplace transform. Right, so this is a very important equation. Equation number 1 gives us the Laplace transform of the derivative of f of t. Right, we move one step further and find Laplace transform of the double derivative of t. Double derivative of f of t. We know the double derivative f prime prime is d squared by dt squared f of t, and by definition this transform can be written as f prime prime t e to the minus st integrated from 0 to infinity. We once again apply integration by parts. This is integrated. The second function is written as such, and whatever we write here is written here, and the second function is differentiated over here. Right, So now we put these limits 0 to infinity. E to the minus infinity is a 0, therefore this first term becomes 0. E to the minus 0 is a 1. 1 times f prime of 0 is f prime of 0, where f prime of 0 is a value obtained by first computing the first derivative of f of t and then putting t is equal to 0. Right, and this second term, and if we look at this, this is actually the Laplace transform of f prime of t, and we have computed this transform in equation number 1. This is s times f of s minus f of 0. So we replace it from equation number 1 and solve it further, gives us the Laplace transform of f prime prime at t is s squared f of s minus s times f of 0 minus f prime of 0. In general, for any derivative f prime 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 of t, third derivative, fourth derivative, fifth derivative, etc. This is the general formula. Right, now we are ready to solve an example where f of t is given to be t sine omega t, and we are asked to compute Laplace transform of f prime of t. We know from equation number 1 that this is s times f of s minus f of 0. Right, so f of s, this is f of t. So first compute f of s. F of s we studied in CVT-18, the last lecture, that if you multiply t with any function f of t, the derivative is minus d by ds of the derivative of the second function, of the Laplace transform of the second function. We studied that in CVT-17 lecture. So t sine omega t has a Laplace transform of minus d by ds times the Laplace transform of sine omega t. We compute this derivative and it comes out to be 2 omega s over s squared plus omega squared, the whole squared we studied in last lecture. So now we are all set to compute this Laplace transform of f prime of t, because f of s is the only unknown. It was the only unknown that we have just computed, this one. S times f of s minus f of 0. F of 0 is obtained by putting 0 in f of t. 0 times sine of 0. 0 times sine of 0 is also 0. 0 times 0 is a 0. So Laplace transform of f prime of t, the first derivative of f of t, is this for this f of t. Right, now we move on to the last part of this lecture, where we are going to compute the Laplace transform of f prime prime of t. That is, from equation number 2 we can write it like this. We have just derived it in equation number 2, this one. Right, so now the unknowns are f of s, which we have just computed, this one, 2 omega s over s squared plus omega squared. Let's see what else do we require. We require f of 0 is 0, we know, and f prime of 0. F prime of 0 is obtained by first computing f prime of t. F prime of t, f of t is t sine omega t. T sine omega t. So we consider this as the first function. We apply the product rule. This as the first function, this as the second function. We write first function as such and compute the derivative of the second function. Then we have a plus the first function as such, the derivative of the first function and the second function as such. This we studied in school and college. So this is what we have done here. F of t is t sine omega t. F of t is t times sine omega t. So what we are asked to do is to apply f prime of t. So we write the first function as such and compute the derivative of the second function plus the derivative of the first function, which is 1, and the second function as such. Now we put a 0 here to compute f prime of 0. 0 times cosine of 0 plus sine of 0. 0 times cosine of 0 is a 1 plus 0. So fortunately or unfortunately, f prime of 0 is also 0. So now we are all set to compute Laplace transform of f prime prime of t. S squared 2 omega s plus s squared plus omega squared the whole squared f of s computed in on last page, this one, minus s times f of 0 is a 0, f prime of 0 is also 0. So Laplace transform of f prime prime of t is this. Right, that's all for this lecture. We'll keep on studying more about Laplace transforms in our next lectures. Thank you.